Hello. Now we are going to look at the equations of circles that are not centered on the origin, so not centered on 0, 0. And the equations of these circles are going to look like this formula here. So we have x minus h to be squared plus y minus k to be squared is equal to r squared. The center of our circle, which is no longer at 0, 0, is going to be h and k. So the h here and the k here give us our center, and the number squared on the end is going to still be the radius of the circle, the distance from the center of the circle out to any point on our circle. So if we want to look at the equation of this circle here, we would say, well, we know we need to find the center and the radius. So we have to figure out what the center of this circle is going to be. Well, it is going to go, we start at the origin and go in the door 2, up the stairs 1. So we are going to have our center of our circle is going to be at in the door 2, up the stairs 1. And the radius, because this circle has nice axis crossing points, or not axis crossing points, nice grid crossing points, we can see that we go from here over to here. That's a distance of 2. So our radius of our circle, we can read off of our graph, is 2 units. So we want to know the equation of a circle that has a center at 2, 1, in the door 2, up the stairs 1, and a radius of 2. So our center is going to be at 2, 1. And our radius is going to be 2. And those are the two pieces of information we need to get the equation of a circle. So now we would write down our formula. We'd go to our log tables to make sure we have everything correct. We have x minus h to be squared plus y minus k to be squared is equal to r squared, the radius squared. And now we can just sub in. Our center is at h and k. And I would write that in our log tables. It will tell us the center is at h and k, and I would write that in underneath my coordinates, or where I'm finding my coordinates, just as I have r is equal to 2, so that I can keep track of exactly what I know, because I'm multiplying by a minus here, so the signs of these can get a bit confusing. But I sub in, I have h is 2 and k is 1, so x minus 2, I'm subbing into a formula, so I'm going to put everything in brackets, to be squared plus y minus k is 1 to be squared is equal to r squared. That's going to be 2 squared. And we tidy that up. We have minus by 2 is going to be minus 2 to be squared plus y minus 1. So minus by 1 is minus 1 to be squared. And 2 squared is 2 by 2 is 4. So that would be the equation of that circle. Now, we're not always given a picture to help us. Sometimes we're just given the text, so we can have a look at this question here. We want to find the equation of a circle with center minus 2, 4 and radius 3. So we write down our information. We have the, or in an exam, if we were given this text, we might underline it. We have the center is at 2 minus 4. So that's going to be our, going to our log tables, that would be at h and k. And we know that the radius is equal to 3. So we have our two key pieces of information. We go to our log tables and write down our formula. X minus h to be squared plus y minus k to be squared is equal to r squared. We have our information written down. We have our formula written down. Now we sub in. So h is minus 2. So minus 2, everything in brackets, and we can see why here. If we didn't put things in brackets, we might accidentally write minus 2 instead of minus 2. And we'd lose marks. So then we have y minus 4 to be squared is equal to, and we're told the radius is 3. So that's to be squared. And we tidy everything up, and we get k minus by minus is a plus 2 squared, plus y minus by 4 is minus 4 to be squared is equal to 9. And that's the equation of our circle centered at minus 2, 4 with a radius of 3. Find the center and the radius of this here. So if I'm asked for that, I'm immediately going to go to my log tables and write down the formula directly beneath where I'm given this information. So I have my formula for my log tables is x minus h to be squared plus y minus k to be squared is equal to or squared. And I know that my center is going to be at h and k. So the center is at h and k. So if I want to find the center and the radius, I now have my information from my log tables, so I know what I am looking for. So I can read from here that h is 6, so there's a minus in both of these, so that means that h is going to be 6. And I can see that k is going to be minus 4, because I can see I have minus k here, but I have a plus 4 here. So there must be minus minus 4 would be how the formula would work. So I'd have k must be equal to minus 4. Because if k is minus 4, I'd have minus by minus 4 would give me plus 4 here. And then I know the radius squared is going to be 18. So I know the center is going to be, I have all the information for the center now, is going to be at h and k. I've worked out that that's 6 minus 4. And I am going to have the radius now I need to work out. So I know that the radius squared is 18. And I put that into my calculator to find, or I would take the square root of both sides to get or, and that is going to be 9 by 2 or 3 root 2. So I now have my center and my radius of my circle. Now finally I can be told find the equation of the circle with center or 3, 1 if 5, 3 is on the circle. And we have a graph of that situation here. So we're told the center of the circle is at 3, 1, and we know that the point 5, 3 is on the circle. Well, I know that the distance from the center out to the circle is always going to be the radius of the circle. So if I find this distance here, if I find that distance there, that's going to be the radius of the circle. And that's a piece of information I'm missing, because I know for my equation of my circle, I have to have the center and the radius. Well, they gave me the center in the question, so the piece of information I'm missing is the radius. So if I'm asked this in an exam, my first job is to write down the equation of my circle, because I can see it's not centered at the origin, so I'm going to use my formula here. And I know my center is at h and k. So the piece of information I am missing is going to be the radius. So I'm going to use, I know this point, the center, and I know the point on the circle. So if I use my distance formula, I am going to get the radius of the circle. So the distance from the center to any point on the circle is always the same. It's always the radius. So I use my distance formula. I go to my log tables and I write down my distance formula. x2 minus x1 to be squared plus y2 minus y1 to be squared. And I write down what my 2 points are. I'm looking at the points 5, 3. I'll call x1, y1. And the center is my other point is at 3, 1. x2, y2. So now I can sub into my formula. So the distance I'm looking for is the same as the radius. sub in there. I have x2, everything in brackets, x2 minus x1 plus y2 minus y1. And I tidy all of that up. I can put all of that into the calculator, being careful I put everything incorrectly in brackets. And I end up with the square root of 8, which simplifies to 2 root 2. So the radius would be 2 root 2. So now I can sub all of that information into my equation. I know that my center at h and k, so h is going to be 3 and k is going to be 1. Put that in here. H, k is going to be at 3 and 1. So I have x minus h is 3 to be squared plus y minus 1 to be squared is equal to the radius squared, so root 8 squared. So my final answer is going to be x minus 3 to be squared plus y minus 1 to be squared is equal to 8. And that is how we get the equation of a circle when it is not centered at the origin. And we get our formulas from our log tables. And that is what we need for now.